Hello again students, this is the second part of acids and bases. We will continue with the similarity between acids and bases. To understand that, we will perform this small experiment. This is the conduction of electricity through ions. So you can see dilute HCl is taken in a beaker and two nails are taken in a rubber core and it is attached to a battery, bulb and a switch. So what happens when you turn on the switch? In this case, the bulb glows. Okay. So we can tell dilute HCl solution conducts electricity. Where if we take any dilute base such as sodium hydroxide solution, if you take, the same thing happens, the bulb glows. But if you take an alcohol solution or a glucose solution, the bulb does not glow, it does not conduct any electricity. So why is that, student? Why does acids and bases conduct electricity but not glucose and alcohol solutions? Because they are incapable of producing any ions. The glucose and alcohol solutions cannot produce any ions, but acids and bases can. So what ions do acids produce? It produces H plus ions. What about the bases? Bases produce OH minus ions. It will conduct electricity using OH minus ions, and the H plus ions cannot exist in free state. In next slide, we will check what then how does it exist in water. So this is one similarity between acid and bases.
Register today at KLM Institute for free online classes, revisions, doubt clearance, private online and offline classes, Olympiad exams, and win prizes, scholarships, and much more.
So now what happens when you add a concentrated acid or base to a water solution? So if you make a solution of it, what happens? We'll take HCl and add to water. So what do we get is we get hydronium ion, okay, plus Cl minus ion. So we have two ions. I told you H plus ion cannot exist in any form because it is highly unstable. So H plus ion is adding to water molecule, and here the H becomes 3. You can see here, but it gets a positive sign. So this is known as hydronium ion. This is actually what conducts electricity in the acidic solution. And also there is a lot of heat generated. It can be known as an exothermic process. So with this, in the same way, we can take base such as sodium hydroxide and add it to water. We are getting Na plus and OH minus, that is the hydroxide ion. Here also we are getting a lot of heat. So this also is an exothermic process. Student, this is a sign of caution. I am telling lot of heat. That's why when we are diluting an acid, so what is this adding of water is known as? This is known as dilution. From a strong acid or a strong base, if you want to make diluted acid and diluted base, we are adding water to it. So when you are making diluted hydrochloric acid, diluted sulfuric acid, lot of heat is produced. That's why we take large amount of water and add slowly some amount of acid into the water itself. We never add water to the acid. because it might cause explosion, or the acid might spill out of the container. So all bases, all acids dissolve in water, but all bases do not. So the bases that are soluble in water are known as alkali, students. So this is a note you can remember. The bases that are soluble in water are known as alkali. So we were seeing the dilution factor and a strong base and weak base. So what is the strength of acids and bases? So how do you calculate it? So a German scientist coined the term potens, which is known as power of hydrogen ions. So this scale goes from 0 to 14, students. The like center of this scale is 7. So any solution, if the pH, the power of hydrogen, if it is 7, it is known as neutral solution. But if it is less than 7, if the pH is less than 7, it is acidic. And if it is more than 7, it is basic. Here, the hydroxide ions are increasing in the basic side. Here, the hydrogen ions are increasing. You can see here increase in the concentration of H plus ion in this direction. Here in this direction, we can see the decrease in concentration of H plus ions. So this is the strength of, this is how we know the strength of an acid or a base. So is it just for laboratory purposes? Not at all. pH plays a very important role in our ecosystem. Let's see how that happens. So students, I hope you all are aware of acid rain. So how does this acid rain occur? What do we categorize as acid rain? Is the pH of the rain falling from the sky should be less than 5.6 pH. Okay, this rain we consider it as acid rain. So where does it affect us? It affects everywhere. When this acid rain goes to rivers and ponds, it affects in small level and large level too. Some pond fishes need a particular pH. When this small pH water is accumulated in a pond, there will be disturbances and death of sea animals, aquatic creatures in the waters. And also we can see trees are killed by acid rain. And also the Taj Mahal is getting destroyed by acid rain. So also we, if you studied in biology, the pH of HCl is very low. That is, it is approximately 1.2 pH. Okay, approximately. Where is it produced? It is produced in the stomach. So when the food is digested, we need this pH. But if there is indigestion in your body, you will you will get acidity if this pH is maintained in your stomach and there is no food inside your stomach. That is why if you might see your elders taking antacids, that is a base to neutralize this reaction. Also, if you chew food, then there will be little food debris in your tooth. So this food debris can form bacteria, and at pH 5.5, some bacteria digest this food for their benefit. But for us, we can see there will be cavities inside our teeth. So this is the pH in our body, students. Also, you should know the bee sting. Have you ever been stung by a bee? I hope you do not get ever stung by a bee, because the bee sting is pH around acidic level. So what happens when it releases acid in your body is it causes irritation and itching. So an easy remedy for this is baking soda. Okay, baking soda. Also, there are other naturally occurring acids in our ecosystem. That is vinegar, which is acetic acid. Orange has citric acid. Tamarind has tartaric acid in it. Tomato has oxalic acid. And sour milk has lactic acid. Also, curd has lactic acid. It is very essential for our body in small amounts. Lemon has citric acid. We gave this example for an acid. And ant sting also is methanoic acid, and nettle sting is also methanoic acid. These are some of the naturally occurring acids, students. So students, let us study more about salts. We know acid and base gives us a salt. So when it is strong acid and strong base, we get a neutral salt which whose pH is 7. But if there is a salt formed by strong acid but weak base, we get acidic salt, which has pH lesser than 7. If we reverse it, that we take a strong base and a weak acid, we get a basic salt, students, that pH is greater than 7. So how do we get common salt? We already used this reaction before. We take hydrochloric acid and sodium hydroxide. We get NaCl.
Give your imagination wings. If you're willing to write something, what are you waiting for? Share your ideas and thoughts. Let your ideas reach out to millions. Get your articles published through our blogs for free.
Students, why is NaCl so important for us? Because it is used in the production of so many things in industries. First thing, we'll see how to make sodium hydroxide, that is NaOH, from NaCl, that is sodium chloride. So this process is known as chlor-alkali process, because what is chlor here? It is Cl, and an alkali, what is that? Na. You can see here, we are taking anode and cathode, two rods here, and connecting it to anode and cathode. Okay, and we are passing brine solution, that is NaCl. We are dissolving in it in water, and we are sending it through the anode and cathode and turning on the power. We are getting Cl2, we are getting H2, and we are also getting a solution containing NaOH, that is sodium hydroxide. Let's see the reaction here. NaCl, which is in aqueous medium, with water, that is in liquid medium. If there is a potential difference, that is we are conducting it with electricity with anode and cathode, we are getting NaOH in aqueous state, that is it is dissolved in water. We are getting chlorine gas, students. You should note the physical states here. We are getting chlorine gas and we are getting hydrogen gas. So why is this process very important? Cl2 is used for water treatment in swimming pools, and disinfectants, CFCs, pesticides. There are so many use of Cl2 gas. and hydrogen is used for fuels, margarine, ammonia for fertilizers. There are so many use of hydrogen too, and we are also getting our main product, which is sodium hydroxide. We use sodium hydroxide in labs. We already know that. It is used in making of soaps, detergents, and papers, and degreasing of metals. So many uses, students. This is known as chlor-alkali process. So the next product which we get from salt indirectly, we already saw in the last process that we are getting Cl2. You can see here Cl2 is used in this process with the calcium hydroxide. We are reacting Cl2 with calcium hydroxide, and we are getting something known as bleaching powder. The chemical formula for bleaching powder is CaOCl2 and water. So you should already know the uses of bleaching powder. We use it for bleaching of cotton and linen, and we use it as an oxidizing agent in many chemical industries, and to make drinking water free from germs. We use some bleaching powder. We used to use that, but some studies show it is very in excess. It is very harmful for us. So we are reducing the use of bleaching powder in drinking water. So when you eat pakoras, garam garam pakoras, and the pakoras are very soft, student. Why are they soft? We add baking soda. So we also get a byproduct of salt, which is NaCl. Okay, if we take NaCl with water and we pass CO2 plus ammonia in it, we get ammonium chloride. Even this is used majorly in labs. If you go to higher classes, you will understand the use of ammonium chloride, and we are also getting sodium hydrogen carbonate, which is commonly known as baking soda. So what are the uses of baking soda? We are using baking soda for, I told you, delicious food such as pakoras, and we do not directly use it. We mix it with any acid, that is tartaric acid or oxalic acid. Here is the reaction why you get soft, fluffy bread and dough if you use baking soda. We are taking baking soda in the presence of any acid, and if you add water to it or heat it, you get CO2. What is the CO2? This is a gas. So there will be air spaces. That's why you get pores in your samosas and pakoras. Also, you get little amount of water and also the sodium salt of whichever acid you use. If you use tartaric acid or oxalic acid. And another important use of baking soda is sodium hydrogen carbonate is also an ingredient in antacids. Being alkaline, it neutralizes excess acid in its stomach and provides relief. We studied how our stomach produces a pH of 1.2. It produces HCl of 1.2 pH. So we need to neutralize it when it is not being used sometimes. So we use baking soda. Also, it is used in soda acid fire extinguishers. We also get one more product from salt, such as washing soda. So how do we make washing soda? We take sodium carbonate, okay, and we add water to it. So it produces washing soda. So I think you are seeing this chemical formula for the first time. This is also a salt, students. This is known as hydrated salts. I will talk about it in the next slide. First, we'll see the uses of washing soda. Sodium carbonate or washing soda is used in glass, soap industries and paper industries. It is used in the manufacture of borax. Sodium carbonate can be used as a cleaning agent for domestic purposes, and it is also used for removing permanent hardness of water. So, about the chemical formula, are salts really dry? If you see here, this is in this picture I have illustrated here. If you see carefully, you can see they are dry. You can tell them that you can touch and it's not feeling wet. But if you take copper sulfate crystals, and it is also a salt, by the way, hydrated salt. So if you take copper sulfate crystals in a test tube and heat it, you can see here in the picture on the right side that it changes its color to white. The blue color totally disappears. And also you can see water droplets on the test tube. So what does this mean? They have hydration inside them. So now how do you get back copper sulfate? You just add water and again it turns into a blue solution. Very simple, isn't it? But this has lot of applications, students. One such example is gypsum and plaster of Paris. If you heat gypsum to 373 Kelvin, you get plaster of Paris. You can see there is only two water molecules here, and in the plaster of Paris there is just half a water molecule. In the same way, you make powder of plaster of Paris, you can see here, and add water to it, and you get back gypsum again. So students, gypsum is very hard. So that's why we use it in the cast. If you get fractured or if you break a bone somewhere like your arms, your knees, we get you doctor uses plaster of Paris bandage to keep it rigid, keep it hard. And one some other uses are art. You can they are making lot of beautiful items using plaster of Paris. Also, they make potteries. So this is all about salts, and this is the end of acids, bases and salt. Hope you have enjoyed it. Thank you, students.